Okay, this video is going to cover solving equations using Algebra Lab Gear. So we've talked about what all the different things symbolize. Now we're going to talk about how to use it to solve equations. So this is a review of the symbols that we've talked about already. We have this symbolizing variables, and we'll call it x. We have this one, that was a constant, but now we're going to kick it up one notch and call it a positive constant. And then we're going to have, this was our equation with the balance point being equals. Now we're going to have another item in here. We're going to have this negative constant. So this will symbolize a negative constant. So we're going to go ahead and translate and solve some equations now. So here's our first equation. The translation of this would be 2x plus 4 equals 12. If you don't understand why, make sure you watch my translating equations using Lab Gear. The next thing we're going to do is figure out what we need to get rid of to get x by itself. We want one of these bars by itself. We want over here on the equation, we want just x by itself. The first thing we're going to do is get rid of the constant by putting the constant's additive inverse on both sides of the equation. So visually, that means we have 4 positives. We're going to put 4 negatives on both sides. If you do it to one side, you have to do it to the other side of the seesaw to keep its balance. Over here on the equation side with the actual numbers, we're going to literally subtract 4 from both sides. That's the same thing as putting a negative 4 on both sides of the equation. So now that's going to cancel out. Over here, you're going to have 4 minus 4 giving you nothing. Over here, you're going to have 12 minus 4 giving you 8. Back in the picture over here, these 4 negatives and 4 positives, that's a bunch of 0 pairs. They're going to cancel each other out. Over here, these will cancel each other out, but we still have these others left over. So I'm going to go ahead and bring up this picture now with the things that have been eliminated no longer in the picture. So we have 2 x's left, 8 positive constants over here on the right. That plus 0 is no longer necessary. I'm going to go ahead and rewrite it as 2x equaling 8. So we currently know that 2x's, 2 times x equals 8. To figure out what x is by itself, we want to know what 1x is. One way to do that is to divide the coefficient into both sides. 2 divided by 2 would give you the 1x. 8 divided by 2 is going to give you something else. Also here I'm going to look at dividing it into 2. We have 2 x's, we have 8 constants. Can we divide up these 8 constants so they're equally distributed to each individual x? Yes, you can, and each x represents 4 constants. 8 divided by 2 is 4. So there's your answer. You're done. Now you'd want to go back in and plug it into the original equation and then see if it works out, and it does work out. Let's do another example. If you want, you can pause it, try working it out on your own, seeing what happens. I'm going to go ahead and move forward. We've got our equation of 3x plus 2 equaling 14. We're going to put the constant's additive inverse on both sides. So our constant is 2. We're going to put a negative 2. If we do it on the left side, we have to do it on the right side as well. In the actual numbers, we're going to go ahead and put minus 2 on both sides. You can see here how those are some 0 pairs. It's going to eliminate your constants. Up top, you're going to eliminate 2, but you're still going to have a lot of constants left. The constants have canceled on the left side, leaving you with 0. 14 minus 2 leaves you with 12. Back over here in the pictures, 3x plus nothing is 12. 3x equals 12 over here with your numbers. So now we're going to get rid of our coefficient by dividing that 3 into both sides. You can show dividing by 3 over here so that each one lines up with 4. We're dividing by 3. 3 over 3 is 1x. 12 over 3 is 4. So there's your answer again. You'd plug it back into the original equation to work it out. Alright, let's keep on going. we have this big equation. Pause it, see if you can figure it out. Try to solve for x. We have 4x plus 5 equaling 17. What we're going to do next is get rid of the constant. Our constant is a positive 5. To get rid of it, we're going to put a negative 5 on both sides. Now over on the right side, we're going to show, on the right equation, we're going to show how we're putting negative 5 on both sides. Notice how there's a negative 5 and a negative 5 on either side of the equal sign, just like they were on either side of your balance point. I'm not writing my negative 5 under the variable term. I'm just writing it under the constant. We can cancel these out. That's going to leave you with 0 over here. We could cancel those out. That's going to leave you with something. It's going to leave you with 12. So I'm going to go ahead and rewrite this because we have 4 x's and now we have 12 left. I'm going to go ahead and rewrite it over here as well. The next step is to get rid of the coefficient by dividing the coefficient into both sides. We're going to divide by 4. If I put these into groups of 4, that means I'll have 3 items for each x. So x is 3. And we're done with that one. We're going to keep moving on. Here's another one. Go ahead and try it. Pause the video. Try it out if you'd like. Here we go. We're going to translate it. That's going to be x plus 3 equals 6. We're going to do like we've been doing. We're going to get rid of the constant by doing additive inverse. In this case, the constant is a positive 3. We're going to put a negative 3 on both sides. Over with my numbers, I'm going to put a negative 3 on both sides. You can think of it now as taking 3 away from both sides. They cancel over here. That's x plus 0 equaling 3. In our picture, we can get rid of all the items in red. Those are all 0 pairs that are going to disappear. We have x equaling 3, x equaling 3. There is no coefficient to deal with. I mean, there's a coefficient of 1, but 1x equals 3. So we're done. Here's another one. Pause it, try it out. If you look at this carefully, you have 5x's equaling 10. There's no constant to worry about. In this problem, you wouldn't add or subtract anything to both sides. The thing you would do is get rid of that coefficient by dividing 5 into both sides of this equation. So we're going to divide by 5. Also, we can do the visual. When you have 10 constants and you're dividing them into 5 groups, that means you're going to have 2 for each x that matches up. So x is 2. When you plug that 2 back in, 5 times 2 does equal 10. And that is about it. I hope this helps. Best of luck to you.